Today we'll be looking at how we can express a line mathematically. We know from elementary mathematics that a line can be defined by 2 points. For example, we have point A here and point B here. And we intuitively understand that there can only be one line that passes through these 2 points. However, in this video, I'll be looking at how we can express a line by using vectors. Alright, so we'll be looking at a more sophisticated form to view lines. So we can express a line using either points or vectors. To express a line using vectors, what we first need is a starting point, which we will call A. Now, what is important to note is that A can either be a point with certain coordinates in our frame, or it can be seen as a position vector. But what is a position vector? A position vector is a vector that starts from the origin of our frame and ends at the point we are considering, in this case A. Say our point A has coordinates m and n. Now, what's so special about our position vector, which we will call A, but we will underline it to show that it's a vector? Well, what's special about our position vector A is that, remember, it starts from our origin, which we will call O, and ends at our point A. So to have the coordinates of our position vector A, we will have to subtract the coordinates of point A with the origin. But the coordinates of the origin is expressed by 0 in the x-axis and 0 in the y-axis. Therefore, we will have m minus 0 and minus 0, which is basically m and n. And what we see here is that our position vector has the same coordinates as our point, which obviously makes sense. And now it's important to note that later on we will be using position vectors rather than points. So here I've drawn out a vector u, and what is important about this vector is that it gives the direction of the line we want to construct. Okay, and that's what we call a direction vector. So here we have our line in red, and all we need to do to define the line mathematically is we need the position vector A as well as the direction vector, the vector that gives the direction, u. Most importantly, to find any point B on the line, what we need to do is we need to move using the position vector A. And then to get to point B from point A, what we do is we add or we move a certain number of times by the direction vector u. In other words, to get to our point B from the origin, we first need to use our position vector A. Alright, so we move through via A. And then what we do is we use our direction vector u multiple times. So first we have our direction of u, but to reach point B, we need to add another vector u. And we iterate the same process over and over until we reach our point B. Just like this. It's crucial to really and fully understand what we have done here. Essentially, we have shown that any point B on our line can be reached using a position vector and a direction vector. And that's how we define our line. Therefore, mathematically speaking, a line passing through A is the set of all points, which we call B, and such that the vector AB, so the vector given by points A and B, is parallel to our direction vector u. And this is the mathematical definition of a line. Okay, so here we have a general point B on the line, and A is a specific point which we know belongs to our line, and U is our direction vector, and K is the number of times we multiply U in order to reach any point B on our line. Now remember that this right here is the vector B, so the position vector B. And this makes sense intuitively because remember that we add vectors from end to end. And so the resulting vector B is actually a combination of position vector A and K times our direction vector U. And by adding these two vectors from end to end, A and KU, what we get is our position vector B, which puts together the origin and the point B. Okay, so what I mean by that is our position vector B links our endpoint B and our origin. Another interesting property which I want to touch on is if we rewrite our equation, our vector equation of our line over here in this following form, B minus A equals KU, we realize something important. First, what we can do is rewrite B minus A as AB. In other words, the vector that goes from point A all the way to point B. And what we realize is that AB can be written as a scalar multiple of our direction vector U. Now, why is that important? It is important because it allows us to define a line in yet another way. Essentially, a line that goes through a point A is defined as the set of all points B, such that the vector AB can be written as a scalar multiple of our direction vector U. In other words, our vector AB is parallel to our direction vector U. And hence, to determine if any point B belongs to our line, what we need to do is see if our vector AB is parallel to our direction vector U. To conclude, what we have done in this video is we have defined a line using vectors. And what we will be doing in the next video is give the equation of a line by using Cartesian coordinates. And therefore, we will be giving the Cartesian equation of a line. So instead of using vectors as we did here, we will be using the coordinates of our points. So thank you for watching this video. Leave a comment if you have any questions. Of course, I will be happy to answer them.